It's November 25th, the day I'm making this video. Today in history is, let's see, JFK was buried in 1963 in Arlington Cemetery. Agatha Christie's The Mousetrap opened in 1952 on this date. It was the longest continuously running play in history with over 20,000 performances. And not to mention it's my stepmom's birthday, so I better call her after I make this video. Here we are in Chapter 7. Applications of definite integrals. So we've been dealing with integration and finding integrals and things like that. Just so you can see the kind of like the outline here for Chapter 7. 7.1 integral is net change. Now we've already done that, so we're not going to take any more time right now to do that, but we will when we get ready to take the AP exam in April. We will review those kinds of problems. But so anyway, we're going to start with section 7.2, area between curves. So that's what we're going to do right now. And just so you can see, only two more sections after this one in chapter 7 are the only ones we're going to cover. So by the way, 7.2 is just a one-day lesson, but 7.3 we're going to take up to three block periods to do that one. There's a lot in that one. And then lengths of curves is just another one lesson. So the key concept, though, what I'd like you guys to remember is that we've talked about this before, that an integral adds up. Let's fill this in here. Let's see if you can pause the video and see if you know what I'm going to write. An integral adds up an infinite number of things. So if you can keep that in mind, that's going to really help you in this chapter. Because we're going to not only add up an infinite number of rectangle areas to find the area between curves, but we're going to quickly transition into finding adding up an infinite number of disk volumes and things like that to find volume, and then we're going to get into lengths of curves. We're going to add up an infinite number of line segments. So keep that in mind. When we to apply integrals, we want to remember that an integral adds up an infinite number of things. Okay. Now there's a few things that if you are having trouble in this chapter, you want to refer back to this page to see, why am I having trouble? Well, if you're having trouble, it's probably going to be because you're lacking knowledge or understanding of one of these concepts here. Graphs of parent functions, how to find intersection points. We're going to be dealing with these two today. How to find intersection points with your calculator as well. So we're going to deal with that one as well, and how to use your calculator to find x-intercepts. So all that stuff, the first four, we cover in this first section here, 7.2. And then we're going to get to 7.3, and you're going to need to remember the 30-60-90 and the 45-45-90 triangle relationships. And then, especially in section 7.3, how to draw 3D shapes that actually look 3D. So anyway, that's really helpful in that section. And we're going to start off with, though, how to express the distance between 2 points horizontally or vertically. So just the concept of what it means to how you find the distance between 2 points. So anyway, with all that, the area between curves is where we're going to start. Now your papers don't have these drawings in them, so you might want to just sit back and watch. If I wanted to find the distance between these 2 points here vertically, so just a concept, you probably already have this, but just to make sure. The distance between these 2 points vertically, if this first point has a y-coordinate of 6 and the one on the bottom has a y-coordinate of 1, then the distance between the 2 points would be 6 minus 1. Okay, now I know you know that already, but when you don't have the numbers there and you just have x's, sometimes students take the bottom number and they subtract the top number. So you don't want to do that. You want to make sure you always subtract the bottom number from the top number. So it's top minus bottom. Okay? And then it also works with negative numbers. So the top number here, the distance between these 2 points, do the top number minus the bottom number. And the bottom number, the bottom y coordinate, is -4. So the distance between the 2 points is 7. Okay? And then one last one. This is the one that students make the most mistakes on. Let me adjust here. Is when you go right to left or left to right. So what do? So a lot of times students think, oh, the top to the bottom, well, that's going to be the left to the right. No, that's not true. So the distance between these 2 points, it wouldn't be -2 minus 6. It would be 6 minus -2, which would be 8. So the distance between these 2 points is 8. That means that if we want to find the distance between any 2 points, which is what you will have to do when the points are horizontally laid out, so horizontal between this point and this point, we're going to go right to, or minus left. So right minus left, and that's going to give us the distance between those 2 points. So I'm going to stop the video now and then we'll get into the lesson.